So from yesterday, we know that our angle of rotation for this particular example was pi over 4. I am going to replace my x's and y's with these equivalent equations, and the reason I want to do that is because this equation does have the xy term in it. If it didn't have the x times y term in it, I would not do this. I would just go ahead and do my regular conic type of completing the square and such. But because I have this term which has an x times a y in it, I'm going to have to do these extra steps.
How did we get pi over 4?
From yesterday. Check your notes, because this is yesterday's A all the way through. It was yesterday's A all the way through. So every example we did A, this is still A. Okay. So now what we're going to do is we're going to replace x's and y's with these equations up here. And to do that, I do need to put in my angle. So I always find my angle first. My x then is going to be equal to, using those equations, is going to be x prime, the cosine of pi over 4, minus y prime, the sine of pi over 4. So the sine and cosine of pi over 4 is nice because it's the same thing. It's a square root of 2 over 2. So x is equal to the square root of 2 over 2 x prime minus the square root of 2 over 2 y prime. Now I'm going to find the same similar type equation for my y. Y is going to be equal to x prime, the sine of pi over 4, plus y prime, the sine of pi over 4. And we end up with y is equal to the square root of 2, that's a terrible 2, square root of 2 over 2 x prime, plus the square root of 2 over 2 y prime. What kind of questions do you have for me so far? Anything? Okay. Now, I'm going to use this information to replace in this equation over here. So let me go over here and erase that off. In this equation here, wherever I see x, I'm going to replace it with this x. Wherever I see y, I'm going to replace it with this y. It's not difficult, it's just a lot of algebra and it's easy to get lost. So I'm going to replace x with that x there. So this x right here is going to be x prime, or excuse me, it's going to be the square root of 2 over 2 x prime minus the square root of 2 over 2 y prime. Quantity squared. Yeah, I'm getting there. Oh yeah. Oh yeah. The fun never ends in this one. Again, this is not difficult. It's just time-consuming and heavy in algebra. So then, my next term is 2 times x. So I'm going to replace x again with the square root of 2 over 2 x prime minus the square root of 2 over 2 y prime. And then my middle term is not just 2 times x, it's 2 times x times y. So I need to replace y with the square root of 2 over 2 x prime plus the square root of 2 over 2 y prime. My next term is y squared. So plus the square root of 2 over 2 x prime plus the square root of 2 over 2 y prime, the quantity squared. The next term is negative x square root of 2. So minus the square root of x, or x square root of 2. My x again was the square root of 2 over 2 x prime minus the square root of 2 over 2 y prime times the square root of x, or square root of 2. My next term is y the square root of 2. So plus square root of 2 over 2 x prime plus square root of 2 over 2 y prime multiplied by the square root of 2. And don't worry, I will show it again, and then minus 6. Okay. So I'm going to go through this again. Just let me go through this again. This was the x squared. This was x. This was the y. So what I have so far is x squared plus 2xy. This was the y squared. This was x multiplied by the square root of 2, and it's a minus. This was y, the square root of 2, and it was a plus. And then minus the 6 is equal to 0. How are we doing? It's not hard, but it is heavy in algebra. Yes. You just turn your paper sideways. The 11 by 14. Okay, now Fred, what was your question? Okay, and I was going to get back there. Okay, so now what I have to do is the algebra parts of it. So I'm going to complete the perfect square trinomials where it's appropriate. I'm going to distribute where it's appropriate, and I'm going to do the difference of squares where it's appropriate. So coming back to my first grouping, this first grouping right here is a perfect square trinomial. This is of the form a minus b, the quantity squared. So I'm going to have my first term squared minus 2 times my first times my second plus my second term squared. So I'm going to treat it as such. Okay? So this first grouping is going to be the square root of 2 over 2, the quantity squared, x prime squared, minus 2 times the square root of 2 over 2, the square root of 2 over 2, x prime, y prime. Oh, it expands in all of its glory. And then plus the square root of 2 over 2 squared y prime.
So that's just from that first term?
Yeah, it's just the first term. None of these are going to be on the test. So that's just the first term. Expand it out.
Y prime squared?
Yep, and it's going to be squared. So this is x squared. That was x squared. So now I'm just going to clean this up before I move on. So this is going to be 2 over 4.
I'm saying this to my friends and be like, y'all don't even know what it is.
Do you want me to write the entire thing before you take the picture?
I was about to ask if you could just scroll over so I can just record it.
Here you go.
I'll wait until you get done with it.
You take a picture of that and say, this is what we do in math every day.
No, hold on. I'm going to wait until you get done with it all, pull it out, and I'll be like, yeah, this is one problem.
Okay, so back over here. So square root of 2 over 2 squared is 2 over 4. Are you okay if I write 1/2? Yes. Okay. Don't be that way. Don't be hating. So it's 1/2. Now, my middle term is going to be 4 over 2, or 2 over 4. 2 over 4, which is 1/2, multiplied by the 2. So this is just going to be x prime, y prime. That's because this middle term here is going to be 2 times 2 over 4. Okay, so that middle term is going to be 2 times 2 over 4, which is just 1. And then it's going to be plus 1/2 y prime squared. So that is just my first term. Now, my second term, do you want me to do these individually, or you want me to just do one big fell swoop?
Just keep doing the whole thing.
Okay, yes.
What are we trying to do again?
Enjoying the algebra. So what we're doing is we are trying to make this conic so that it's something we can graph on a rotated axis.
Okay.
Yeah, we get lost in all the glory of this. All right, my next term here, so let me just go up and erase part of this stuff. So let me erase this. My next term is going to be a minus b, a plus b. So it'll be a squared minus b squared. So I'm going to use the difference of squares for my second term when it expands out. So when my second term expands out, it's going to be 2 multiplied by, it is going to be the square root of 2 over 2 y x prime, the quantity squared. And it's going to be minus the square root of 2 over 2 y prime, the quantity squared. That just represents the 2 times x times y. This represents 2 times x times y. So this is going to become, inside here I'm going to get 1/2 x prime squared minus 1/2 y prime squared. When I distribute this 2 out front, what happens to those 1/2s? They cancel themselves out. So this is just going to be plus x prime squared minus y prime squared.
The 1/2 comes out to?
Yes, and that's because this 2 right here, this 2 right here will distribute through.
Oh, for everything. Okay.
Yep. Moving on to the next term, which is the y squared term. I'm going to use the fact that this is a perfect square trinomial again. This is a plus b, the quantity squared, so that gives me a squared plus 2ab plus b squared. So this term is going to be the square root of 2 over 2 x prime, the quantity squared.
This is a plus b squared?
Yep. Plus 2 times the square root of 2 over 2, the square root of 2 over 2, x prime, y prime, plus the square root of 2 over 2, y prime, the quantity squared. All of that I just wrote is my y squared. Now we know, what?
Do you enjoy doing this? Like in your free time, is this something like you do? Yeah, I got this.
Only if I've had a couple of drinks. So now we know that the square root of 2 over 2 squared is 1/2, okay? And we also know from our previous one that this just becomes 1 x prime, y prime. We know from our very first one this is 1/2 x prime squared, and we know this is going to be 1/2 y prime squared. So we know that from our very first expansion. So I'm going to put that on my next row. So this is going to be plus 1/2 x prime squared plus x prime y prime plus 1/2 y prime squared. Oh, the glory never ends. My next term is going to be distributing the square root of 2 through. When I distribute here the square root of 2 onto both of those two terms, I'm going to have 2 over 2. So it's going to be minus, because there's a minus there, so it's going to be minus x prime minus a y prime. This term is x the square root of 2. Yes?
I know it probably really doesn't matter because there's so much going on, but when we rewrite it out, can we put the square root of 2 in front?
Absolutely. Absolutely. So then I'm going to write this down here. So this is going to be minus an x prime plus a y prime, because I've distributed that negative through. Because I've distributed that negative 2 through. Now my third line here is the simplification of what I'm doing. So the third line is this negative is going to distribute through, and that's why it is minus x prime plus y prime. Now, my second to last term is I'm going to distribute the square root of 2 onto both of those. I end up with 2 over 2, which just gives me 1. So plus x prime plus y prime, and then minus 6 is equal to 0.
We don't do anything with 6?
No, we're going to have a break from that. So I have plus x prime plus y prime minus, it's minus, right? Minus 6. So this is where we are right now. Oh, it's not done yet. This is where we are now.
It looks good. It honestly doesn't come.
Doesn't it look kind of cool, especially with the colors and stuff?
I can see a little tuned up, like, yeah, I'm gonna bust this out.
Bust this out. Have a couple of beers Friday night, bust this out. Okay. So what I'm going to do now is I'm going to combine up like terms. So I'm going to start looking for x primes. I'm going to start looking for y primes. So I have a 1/2 x prime squared, and I have a second 1/2 x prime squared. Now those two are going to combine into x prime squared, because 1/2 plus 1/2 is 1. I have a 1/2 y prime squared, and I have an additional 1/2 y prime squared. So this is going to be plus y prime squared. So I've taken care of this term, this term, this term, and this term. I have a minus x prime y prime, and I have a, where's my other one? A positive x prime y prime, so those go away. I have an additional x prime squared and minus a y prime squared, so I'll take care of those in a minute, so I'll get rid of those. Then I'm going to look at my x primes. Well, this x prime here cancels with this x prime, so those go away. And then I'm just left with plus 2y prime minus 6 is equal to 0.
Where's that 2 come from?
Because I have a y prime and a second y prime, so I have 2 y primes. What happens to my y prime squareds now? So I have x prime squared plus x, 2x prime squared. So I have 2x prime squared. That comes from this one and this one. And then plus 2y prime minus 6 is equal to 0. Let's divide everything by 2. So I have x prime squared plus y prime minus 6 is equal to 0. What kind of conic is this? Oh, I do. Thank you. Okay. What kind of conic is this? How many things are squared? What kind of conic is this? Parabola. So let's put it in the correct form. It'll be x prime squared is equal to a negative y prime plus 3. Still not completely in the correct form, because in the correct form it would be x squared is equal to 4p y minus k. So I do need to factor off that negative. And so I have x prime squared is equal to a negative y prime minus 3. So even though this was horrendous for a moment or two in time, okay, I'm trying to convince you, it was just a short period of misery. Got to work on that poker face. 25 minutes to this is why it's not on the test.
Zoom her out. You can see.
Well, let me do the graph
Okay,
too.
that's fair.
Well, actually,
Okay.
no, you just because I need. Well, okay, so let's zoom out to where there it is in all of its glory.
Oh, yeah. The graph is there, right?
Yeah, I'm gonna do the graph in a minute.
Yeah. Yes, man. Does that mean p is negative 1/4?
That means yes. Well, it's going to be a negative number. Yes, p is negative 1/4. Yep. All right, are we ready? Here is my graph. Let's see if I can do this with my cool snapping tool. Nope, that's not it.
You draw your own like cool little graph over on the side.
Here's my cool little snapping tool. Let's see if this works out. Look at that. I'm so proud of myself. Look at that. That's like the best line I've ever had. Anyways, so that is, I should probably do that in a different color though. I'm just so proud of myself. Okay. Let's do this in blue. Sweet. So proud of myself. What? That was awful. I was proud for a moment, okay? Okay, now this is the rotation of axes. That means this is my x prime and this is my y prime. It's a 45 degrees, so that's my x prime and my y prime. If I go back down to my conic was a parabolic shape. My p-value, so we know that 4p has to equal negative 1, so p equals negative 1/4. The vertex on this is going to be at 0, 3. That's where my vertex is, and it's going to be upside down. So I'm going to come back over here to my graph. It's going to be 0, 3, so I'm going to go to 3 on my graph, be right about there. And that's where my vertex is. This thing is upside down, so it's going to have a shape like this. All and that's how come if you're an engineer, you charge somebody $1,000 to come out and look at $1,000 and $1,001 to come do a job, and they ask you what the $1 for, and they say that's for the chalk, and the $1,000 is knowing how to do it. So here it is in all of its glory, just to do that graph. One problem. Now, I want you to do B and C in the next 20 minutes. Actually, what I'd like you to do... Don't worry, it was I seen it, it was the clock.
Oh, yeah.
It was the clock.
How did you know it was upside down?
Because my p-value is negative. Oh, yeah. It just kind of eclipses all the other ones. So what I'd like you to do in the next 10 minutes is see if you can start doing the setup. That's all I ask for, is start the setup.
What's the 1/4 doing there? Negative 1/4, I mean, how's that be
Where does the negative 1/4 come into play?
yeah, what is it doing in the graph?
The negative makes it go upside down.
What's the ratio?
The 1/4 tells me how far away I go to my focus and how far away I go to my directrix. All right, so what I want you to do on these two is I just want you to get the setup. So what I'm asking for on these two is I just want you to find your x replacement and your y replacement for each one of these. So just find your x replacement and your y replacement. So I'll give you about 10 minutes to give you the x replacement and the y replacement, please. Looking at just the setup parts of it, what did we find from yesterday? What was my theta from yesterday? Pi thirds. So my x is going to be the cosine of pi thirds x prime minus the sine pi thirds y prime. So that gives me x is equal to 1/2 x prime minus the square root of 3 over 2 y prime. How was that? Meh. Y is equal to, it will be the sine of pi over 3 x prime plus the cosine of pi over 3 y prime. So my y replacement will be square root of 3 over 2 x prime plus 1/2 y prime. How was that? Cool. What was my angle of rotation for C? What is it? So then I have my x is going to be the cosine pi over 6 x prime minus the sine of pi over 6 y prime. So my x is going to be equal to x. What is this happening? Okay, x is going to be equal to square root of 3 over 2 x prime minus 1/2 y prime. Then I'm going to do the y, so y is equal to the sine of pi over 6 plus x prime, so let's put the x prime in there, x prime, plus the cosine of pi over 6 y prime. So this is going to be equal to 1/2 x prime plus the square root of 3 over 2 y prime. How was that?